Okay, good day again. So we go to lesson two. I'm going to look at these erosional landforms, looking at headlands, bays, coves, cliffs, and wave-cut platforms. Um, so we've got here the definition again about what erosion is. Erosion is, okay. And we go through the difference and these erosional landforms here. So make a note of this from this page here. And we'll go into, so where's the information? Go through those pages that are on there, okay? And I'm going to go over these key terms, okay? Try and match those. Yep. Once you've matched those, then note down these main words for the different types of waves because they'll come in handy, okay? So if you read Bunnett 139 to 140, reviews the types of erosion on 138, also highlights how erosion takes place between low and high tide levels. The force of the breaking storm, how you could have almost like a 20-ton weight upon 1 square meter. Okay, so the power against that rock is phenomenal. Okay, read through the landforms that are produced by wave erosion. Read through that. How erosion begins with like a little mixture of notch and crack there, between a notch and a crack in the land. That little crack in the land will get bigger. The bottom of the cliff becomes eroded, while the top of the cliff is weathered, but not as quick as time. And in front of this is a broken surface. Okay, so as the top collapses, as we showed in that first lesson, it then lands in front and creates this area of rock in front of the cliff, which is called a wave cut platform. Okay, but let's start. That was just like an overview, and let's just go through. Why is it the shape of a headline is kind of very different in different locations, okay? And we're going to think about what this concordant and discordant coastline is, okay? So, if you look here, what is the important factor that is impacting the headland here? And as you can see in the key, yeah, it's the geology again, okay? So, concordant is similar types of rock along the coastline that are parallel, okay? So it's almost in across here. So this area here, where my cursor is here, these are parallel. So we've got like one band of rock, one band of rock, one band of rock, okay? Here, one band of rock, one band of rock, one band of rock, okay? While discordant, different rock types along the coastline, okay? So here, so you can see that these erode at different rates. So here, the clay is eroding much quicker than the limestone here, and this is creating this headland that's created here, okay? And so this concordant, discordant impacts upon it, okay? And so we have these headlands here, while here, we'd have coves that develop, and we'll look about how they're developed. Now, wave refraction, so if we have some bits that are eroded more here, these bits stick out, and then these bits here, this headland here gets attacked due to this wave refraction, okay? So it's diverted as the swell bends, it reaches and crashes into that headland, okay? And so there's less of the waves energy in the bay area here, okay? So we've got this little diagram that goes through this. Harder rock, softer rock. Waves attack the coastline and boom, the softer rock goes and the harder rock, and then they've got these headlands that stick out here, okay? Forming a bay, and less resistance, called a headland. Here, it's more sheltered and there's more deposition and beaches are formed. Okay, and I've got this diagram here, so you can have them out, so you can draw them or print them out. So you've got a diagram that shows these discordant headlands, okay? Now, if you look here, where's the headland, the bay, you can see, and here, and you can see how it would show on an OS map, okay? Now, what about on the concordant coastline, okay? Here, a river might develop here and cut through in the valley, and then this area here develops where we've maybe got the softer rock here behind the front for the coastline, and a cove develops here. The water kind of goes here, goes from the river, and then it forces its way through. Okay, so we have a kind of a small headlands here, and then this large cove in the back where erosion has taken a place a lot behind it. Okay, so read through those diagrams, write them out. So that here, that's Seven Sisters. Now we're going to look at, I talked about wave cut platforms. Now watch this video, it's really important, okay? So that you can then use this diagram that goes through how it's attacked below, the overhang, the different process of a hydraulic action, attrition and corrosion, and over time the cliff retreats, and then we have the beach in front of it, and we've got the wave cut platform in front of it, okay? The wave cut notch, as it keeps knocking away below it, then there's overhang, and it drops down again, okay? So read through pages 140 to 150 to review these points that I've briefly gone over. Now we're going to look at Bahamian examples. Now, one, it defines coast as any area of exposed rock, okay? Then it gives an example of ridgeland, e.g. By the sea in Clifton, where the cliffs can be about 10 meters high, okay? They give other examples on page 94. Another name they use for cliffs are bluffs. The examples named above are close to the ocean or deep water channels, so there's little protection, okay? So there isn't coral reefs or shallow protection right in front, so that gets the full wave force. Examples of cliffs was Lutheran Glass Window Bridge. They're exposed to the Atlantic shore, which has a great fetch. So think about, as I talked about earlier, about the surfing in that area. Now, if it was in a rockland landscape, then the cliff will not be very high. Page 96 has examples of large blocks cut by waves in San Salvador, etc. Okay, so you can go through that. Now, for your task, for your assignments, can you complete this worksheet by describing the processes of how headlands and how wave cut platforms are formed? Okay, for the final lesson then for this one, we're now going to look at sea caves, arches. Now notice I said sea caves just so you don't get confused with the caves that we've done previously, stack stumps and blowholes. Now we talked about that wave refraction as the headland is being attacked. And this creates these erosional processes. So first there might be a crack, and then that crack becomes bigger, and it could become a cave, and then get through to the other side, and it creates an arch. Then what happens is that either side, and it can't support that arch. It collapses and it's broken away, and then we have we have a stack, and then left with a stump. Now, if you go to, have I got the video link? Yeah, I've got the video link here. So if I give you some examples of each, so that's a view from inside a cave. So imagine many years ago that maybe there was an arch here, or previously it was all headland, and then it's just slowly been eroded away. The bottom here, we can see it's been attacked to the bottom here. You can see where the high tide would go from there, and then over tide, and that will collapse, and it will become a stump. Here, the arch still exists. Sadly, the arch, well, I don't know why I say sadly, but the arch doesn't exist there. That's kind of become a stacky stump there anyway. The example, the fact that there used to be an arch in Eleuthera, and now they've had to build in that after a hurricane in early 1900s. So look at the diagram that goes through each step along here. One, crack, cave, arch, stack, and then a stump. Watch this video, it really explains it well, okay? It'll help. In page 141, it explains how caves, arches, stacks, and stumps are formed, okay? Use the video and that page to work to make your notes. Pictures of examples of erosional landforms show the headlands of resistant rock left exposed to the processes. Remember everything from lesson 1. Page 1.3, you need to know these diagrams. Page 1.4 shows how a blowhole is formed, okay? And how it can eventually collapse to create an inlet. So imagine the cave is eroded, and sometimes a small part of the ceiling collapses, and when the sea comes crashing in, so you could be on the top of the cliff, and then suddenly this hole in the floor and water comes flying out of that, okay? That's just a sign that there's a cave below that might be getting ready to collapse, okay? Make sure you've made notes of these honeycomb weathering, okay? this jagged, sharp rock that's left behind on some Bahamian coastlines, formed through biological weathering, and blowholes, which I've just explained here. Now, notice how the app said how they use sea caves. Exuma Keys has great examples of sea caves. Further examples of how blowholes are a sign of cave collapses. Preacher's Cave in North Eleuthera is a good example with caves of blowholes. Arches, the glass window bridge of Eleuthera was an example of an arch that was destroyed in 1926 during a hurricane. The honeycomb weathering then. So the spiky rock is likely to be fossilized plant foods called rhizomorphs. So when the ridgeland was formed, so the sand dunes, there may be those plants growing in between them, okay? And these roots of these plants were secreted substances that hardened that soil, okay, and the sediments around it. Now, as the other parts of the limestone erodes away, these rhizomorphs stand out as spiky protection because they don't erode away so quickly, okay? If you look on figure 7.21 in your Bahamian landscapes, there's some great examples. And there's so many keywords here, but most of them you should know. And we'll do some of them next week as well, like, for example, bars. We'll do that next week. We'll go through and have that. Now, the assignment. New Wider World, page 315. Question 1, A, B, C, D, E, I, and double I. Do not do E, treble I, or F and G this week, because we have not done it yet. Okay, complete it on full sentences, and put it on headed paper, and then upload. If you have any questions, then please send me an email. Now, I can't advise enough to watch those videos on that website, Time for Geography enough, okay? And that really should help. Thank you very much. Have a good